Hello everyone, and thank you for joining us for our webinar today. My name is Ben Hutchins and I am part of the Innovise marketing team. Our webinar today will showcase how you can gain better understanding of water losses and leakage. As we move through the slides, if you have any questions, please type them into the question box located in the right corner of your GoToWebinar interface. Since the session today is scheduled for 30 minutes, we will follow up with answers to any questions after the webinar. Your expert for the webinar today is Rebecca Willey. Rebecca joined Innovise 2 years ago, having previously worked at Atkins. She is one of our solutions engineers and specializes in the water distribution product set. She helps provide technical information about the products and how you can fully utilize your software. I'll now hand over to Rebecca to take things away. Over to you, Rebecca.
Thanks very much, Ben, and welcome everyone to this webinar wherever you are in the world. So Innovise's water distribution hydraulic modelling solution, InfoXWS Pro, is what we're going to be predominantly looking at today, and is used globally by water utilities and their supply chain. The solution is a standalone platform, not reliant on any specific third-party information or platform, and uses data sets such as GIS for asset information, controls for the configuration of the network, customer information for the demand, and live telemetry to ensure that the model is accurate and representative of reality. So once created, a model can help you solve many challenges facing the water sector, from design and build optimization to ongoing planning and maintenance, and then into proactive operations. So a one-time investment can really maximize the CapEx and OpEx of a company while ensuring the compliance with regulations and an efficient and safe network for customers. So the challenges and the uses that people have for the software are noted around the screen, some of which we will be discussing in future webinars. But today we are focusing on the monitoring and management of leakage using the hydraulic model and the tools we have available within that. So to start with, just wanted to bring it back and so what we mean by leakage. So we are looking at any water escaping from the pipe and from the system. And while we often think in terms of leakage as a small hole with water loss over a longer period of time, we are really looking at the amount, any amount of water that does not reach customers and that water utilities therefore do not receive payment for. And that can include bursts, and that's why, although overall it is a water loss, it is also referred to as non-revenue water. This is water that is not billable, and because of that it also includes those illegal connections to water supply, people that are taking water but are not paying for it. So why is this important to understand and prevent? It's become a major area of focus for utilities around the world, and part of that has been due to regulation and targets and others to customer pressure. But with changes in our climate in areas of the world that have not previously experienced drought and water scarcity, every drop really does count, and as a resource we want to reduce that loss as much as possible. When we have a leak or a burst, that can also affect the water quality, potential ingress into the pipe, as well as the effects of the network changes when we deal with that incident. And so this is something we want to avoid. We want good water quality standards for all of the time. And when bursts, especially bursts, can cause internal flooding of properties, as well as damage to the utility's network and assets. And really all those things cost the utility money, whether that be in the loss of treated water, so they put the chemicals into that water at the treatment plant, and that's a loss of water. The repairs to those network assets, in reputation damage and the costs that they have to give to customers, as well as in performance objectives and standards that are not adhered to. So ultimately it is really important because it affects people's access to safe, reliable water all of the time. So we'll focus on 3 areas throughout this presentation about how the modelling solution WS Pro and IW Live can really help with this leakage challenge and can help reduce your leakage, whether that be from a starting point, you're starting off your leakage strategy, or you already have a strategy and a team and you're looking to maybe make that more visually available for others in the team. So in order to make the biggest impact on leakage, it is important to look at the full network to identify and prioritise those areas with the highest levels of leakage. And so using the hydraulic model, we have the full network there. We have every individual asset, every hydrant, valve, and down to that customer point. And so some of these assessments really give us that added level of detail. So WS Pro allows us to connect to live data to view your telemetry data alongside the model through a one-time connection, which is valuable for other activities such as calibration perhaps, but it allows you to see the current behavior of the network and pick out any potential network configuration changes that have happened that you don't have replicated in the model. So if there's a change in a DMA boundary, for example, it may look that you have a large increase in leakage, and you can look at those the valving to assess whether that is a configuration change or that something is potentially going on. And with the live data, we can connect to multiple different databases at the same time. So if you have flow pressure in one database and pressure in another, those can be connected to get you that full view of the network. And using this live data connections, the demand area analysis tool allows you to generate your demand profiles based on the flow through a DMA on a specific day, and we can generate both a demand profile as well as a leakage profile. And so by doing the demand calculations within the model, often those are done externally in spreadsheets, but we're using those live data connections, and any changes that are made to the network configuration, those can be, the demand can be easily recalculated. If you would like to do the demand for another period of time, you can easily change the day, and the new demand and leakage curves can be calculated. So it means that your demand calculations are not a one-off process as part of your model building calibration. They can be an ongoing, evolving thing as you have more information either about changes in demand pattern or changes in configuration of the network. And this provides a deeper analysis on the water consumed within each area, which allows all water supply areas to have the background losses and expected leakage calculated. So using the number of customers in the model and the length of main, we can see that actually in this DMA or in this area, in this zone, we would expect this amount of leakage. We are able to get a priority list and visually see these areas on the network, as well as then being able to drill down into the exact numbers to quantify leakage to get the litres a second leakage. The non-revenue water and the ILI is calculated, but more importantly, that excess unaccounted for water. So there will be some expected leakage in an area, but it's really that unaccounted for water where the biggest gains can be made with your leakage reduction. And this can help you focus your project programs to areas where leakage can be reduced the most, and where you will get those biggest gains. So by using, again, the connection to telemetry and those connections to assets, we can look at using the leakage locator tool to identify an area of suspected new leakage. So by seeing a change in pressure readings in an area, if you know the size of a water loss, maybe reported from someone in the ops team or from another system, you can use this to compare the simulated and observed pressures at monitored locations to narrow down the area where the leak might be. This ensures that field crews are targeted to locations for exact identification and fixing. And while this can be used for small leaks as nighttime leakage, as well as bursts that are potentially in harder places to find, so in woodland or areas in marshland perhaps, where it's not as visible, a large burst, this can help you identify those large volumes. And as well as illegal connections. So this can help you look within an area, a zone or a DMA, if you have a large difference in what the model would be expecting with normal demand and the changes in pressure. This can help you identify where you may have some illegal connections. And so a recent addition to the software is the ability to then replicate that burst or leak. So it may be that you found the potential location with the leakage locator, or it may be that you've done your demand area analysis and you've got your leakage prioritization and you want to look at replicating some leaks in those areas to see where they might be and the effect of those. So you can use this tool to select a location on a pipe and select whether this is a complete rupture of a pipe, the size of the break, or a flow rate coming from the pipe. So this can allow you to see the effect that a burst or the water loss has on customers and able to quantify that loss, so how the volume of water lost over time, as well as more importantly assessing, replicating multiple locations for bursts. So the leakage locator can narrow down that area, but that may still be a complex area. And you may want to look at replicating those bursts in multiple locations to see the effect that has. So this can really help someone that's investigating where leakage might be, whether that be looking at DMA configuration and potential breaches there, but as well as locations for leaks and the size that leak might be. So zonal planning, this can be a key factor in reducing leakage. And while it's often a main task to quantify and identify the current leakage, using the hydraulic model, you can understand the full network and investment can then be targeted to reduce leakage, as well as checking other parameters such as water quality and that some supply and pressure is maintained for customers. So pressure management is a global network design method to reduce leakage in specific areas of the network, with pressure reducing and sustaining valves often a key part of that. And so these can be modeled using the inbuilt valves and valve curves that we have within WS Pro. And these can really help you get the optimum location of the valve, the size of the valve, the pressure, as well as the set point that the valve is trying to maintain. So this can be used to really optimize your network, but as well to ensure that those customers will still be receiving pressure based on their profiles, especially commercial users, and these can be checked when doing this within the hydraulic model. So Innovize's engine in WS Pro allows the accurate modeling of these planning exercises for the full network. So we have in there parameters such as the drain down, recharge and pressure related demand functionality, which allows the system to use the pressure and demand in the system to represent this more accurately. when we would be representing or replicating a burst or an isolation in other modeling packages, the results would show no pressure or supply instantly, and this isn't realistic and can generate inaccurate results. So the WS Pro allows these assessments to be carried out quickly, and these tools are all within the package and can be used very easily for your planning exercises to ensure that these results are as accurate as possible. And in addition to these tools, and when using a hydraulic model in general for your planning exercises, the asset management tools we have in Info Asset Planner allow operators and managers to evaluate the structural condition of the network. So looking at the risk and reliability based on the likelihood and consequence of failure. So where might there be potential bursts and leaks in the future? Trying to be as proactive as possible and help you deliver optimized rehabilitation and maintenance plans. So we've looked at quantifying that leakage, looking where that leakage is now, and then how we could plan the network to see where that might be and how we can design the network to reduce that leakage going forward. But obviously leakage keeps happening, whether that be a small leak, whether that be a burst, illegal connections or any type of water loss. And so the ongoing operational real-time management of leakage is also really important to try and be proactive as possible and to stop those leaks getting any bigger. And so one of the tools we have for this, IW Live Pro, is our real-time modeling platform. It's a much simpler interface to WS Pro and is really aimed at a control room environment for people that are making those real-time decisions about the network. So it uses the base hydraulic model from WS Pro. We have demand forecasting in there, as well as updates from telemetry and assets such as valve status. And automatically on a period defined by the utility, a simulation is generated, takes that current network status and runs a simulation to get a representation of how the network is now, but more importantly, how the network is expected to react within the next 24 to 48 hours. And this allows you to see potential issues within the network, whether that be assets or the effect on customers, as well as if you have a problem, you can easily replicate that. So again, using that pipe break tool that we talked about earlier, that functionality is available within this live environment. We can select a pipe, we can specify the parameters of that burst or that leak, and in real time we can see what effect that will have on the network and on customers, and then more importantly, how we can deal with that. So does that pipe need isolating? Which valves do we need to select? And since that is then isolated, is there other things within the network we need to consider? The warnings are probably your first point of call when you would open the software, and these are generated in real time, either on thresholds of live data, more typically that you might have maybe in a SCADA system, as well as on the comparison of the model, what the model would expect to happen, and what's happening in reality. So this can help you see problems potentially before they reach those thresholds that you get in SCADA. So you can see trends of, okay, the model the model would be expecting this with current demand and the current configuration, but we have a large increase in flow, in in decrease in pressure, and we can then investigate that. So you can view the graphs and the live data with this, and as well you can visually see this within the network. So we can have different colours for different areas where thresholds are breached, and try and identify where that might be. So an indication of the location can then be seen. We can look at the largest difference in live data and model data, and give an approximate location about where that might be, much like the leakage locator that we looked at previously in WS Pro. So this solution enables you to report on water loss, so whether that be the volume of water loss, the number of customers affected, what duration, as well as how quickly something needs to be fixed for customers to be affected, or if an isolation is in place for a certain length of time, what effect will that be, and what impact will that be on the network. It can then help validate the location of bursts and their effects in real time, which is what the tool is for, but it can also be great in retrospectively assessing the impact of bursts on customers. So if you did have a large burst, you could look at that simulation from a few days ago, replicate the burst, and see whether the configuration that you did for the valves, how many customers that affected, but maybe some lessons learned for the future. And this, in a simpler dashboard, means that this information can be shared more widely across the utility. It's much simpler for people to easily see. The customers affected, for in this example, are red, and we know that they are therefore below pressure. So much easier to see this information in real time. And so to ensure a full connected utility, when operations are going out into the field, we need that understanding of what changes they might be making, and how that might be impacting the leakage assessments that are being done on a monthly basis, for example, as well as the impact they are having on the live models. And so with WS Pro and Info Asset Manager, these are connected to ensure that seamless management of the network. So somebody in the field with Info Asset Mobile can say that they've changed some valves, and that can go back into IW Live and into WS Pro for new leakage calculations to be made for the next month, as well as then you to say, okay, I've dealt with this burst or this problem, this is what I have actually done, and will that satisfy the response to the incident. As well, we can look at Info Asset Manager, which can set those work orders. So once you have prioritized your leakage and areas you want to send some crews where you have an idea that might be a problem area, the information from WS Pro can go into Info Asset Manager for someone to create a work order for a field crew to go out into the field to investigate, to make some changes perhaps. And then we touched on earlier, this information can all be brought together from the model, from the mobile field crews, to inform the decisions for Info Asset Planner. So looking at that likelihood of failure, how often has someone had to go out to this pipe? How often has it burst before? What would be the consequence of failure from the model? And bring all that together to give you a really informed decision. So while we've been talking predominantly about the use of hydraulic models, we are talking about the management of assets, and so these two really are interlinked. And so I think I've come to the end of my time. So just to say that leakage, water loss or non-revenue water, whatever capacity that might be, a small leakage a leak overnight, a burst, or an illegal connection. There are ways that an investment in the model can really help in some capacity, whether that be identifying and quantifying the leakage, designing your network and optimizing it to be more efficient, and then moving that into the real time to ensure that you're ongoing and proactive with your network. So now I'll hand back to Ben.
Excellent. Thank you, Rebecca. As I mentioned in the introduction, since the session today is scheduled for 30 minutes, we will follow up with answers to any questions you have after the webinar. We are currently finalising the schedule for our series of September webinars, and I'll be in touch with details about them and a recording of this webinar next week. In the meantime, I have posted links to recordings of all our recent webinars and event presentations in the chat. You can watch these presentations recordings on demand at any time. Please also do remember to take a moment to complete the survey that follows this webinar to get an attendance certificate. And as always, check out our website for details about Innovy's training courses. Finally, a big thank you for joining us today. Have a great day, everyone.